G'day and welcome to this, our language of polynomials, the video tutorial. Swift on the heels of the previous one. So, polynomials are fabulous things, alright? And so let's do, as we usually do, a quick little recap of what's gone before. So previously we looked at how quadratics were a really useful part of mathematics. We would hope so. They've so far been taught in year 10, year 11 and now year 12, right? You'd have to hope that the language behind polynomials and quadratics actually meant something. Right, now we've looked at solving them by putting them into, by putting a quadratic equation is equal to 0. That's solving them, if you remember, is trying to find where this quadratic crosses the x-axis. And why? Because that's also known as the line y equals 0. Right, so by putting a quadratic of y equals x squared plus 3x minus 6, for example, when we put it equal to 0, we are finding the points where it crosses the x-axis. Now we've looked at how to factorize them, and I've shown the t method, I've shown the cross method, the quadratic formula, and completing the square. Right, now completing the square the way I do it actually puts it in turning point form. And in a previous video, we looked at the discriminant, which, if you remember, is b squared minus 4ac, which comes from the formula x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And the discriminant is this thing under the square root sign, which we know being a square root cannot be negative. And so we look at the values where that is less than 0, equal to 0, or greater than 0. And that tells us whether there's going to be 2, 1, or no roots to a particular quadratic equation. If you don't remember this stuff, please stop and go back and watch the video on this. But let's just do some basic language with regard to polynomials. All right, so this leading term here tells you the degree of the polynomial. So in this situation, you would say it was a degree 2. Why? Because the highest power is x squared. And because that is a little floaty 2, that is why it's a degree 2. This whole term here is called the leading term, and this term here is called the constant term. Now, if you remember, maths is a lot of language, right? And so if ever they give you an exam question and start talking about degrees, right, they're probably not talking about what we use in trigonometry. They're probably talking to you about what is the degree of this polynomial. Now that's the language dealt with. Then we move on to this, finding the value of the polynomial. And those of you who've skipped ahead and paused and are reading this cartoon, I have to say Calvin and Hobbes cartoon strip, absolutely phenomenal. Right? At no point was its inclusion meant to contravene copyright, but I have to say it packs a punch and says something that I actually think is quite important. But before that, let's go back to finding the value of our polynomial. So if we have a polynomial, for example, this here, and notice in this situation it's given by p of x. It could as easily be given as y equals, but let's say that we have a polynomial in terms of x of 8x cubed minus 3x squared plus 4x minus 3. This language here is incredibly important. The first year I taught over here in Australia, I have to say, an examiner's report suggested that students in my group had no concept of what this actually meant, or this, or I don't know, this. They had no concept, sadly, of knowing that what it meant was substitute the value of 1 into the equation that is p of x. And if you notice, what do we notice? They are basically the same. What has happened? X has been replaced with the value of 1, and that's what it's asking in the question. So here, if I look at directly substituting 1 in, well, I get 8 times 1 cubed minus 3 times 1 squared plus 4 times 1 minus 3, which when we simplify that gives me 8 minus 3 plus 4 minus 3 and 6. Now this particular idea of substituting your values comes in really, really useful in a later video, but I don't want to rush. I just want you guys to realize that when there's a number inside these brackets, the chances are it just means find whatever function z of x is and substitute, in this case, the number 3 for x, right? Please don't. That actually, funny enough, these type of questions come up ever such a lot on the method stream for exam. So, as I said here, maths is about teaching things forwards and backwards. In my previous lesson, we talked about unidirectionally teaching maths, and we as maths teachers pretty much forget that sometimes we need to teach you both forwards and how to do things backwards. This doing things backwards is what I call testing understanding. And as Calvin said here, if you look at his test, he's being asked a question. He puts 1620, which I'm imagining is the correct answer. But then, very typically for Calvin, who is a 6-year-old and has probably a better vocabulary than I does, basically says, well, as you can see, I've memorized this utterly useless fact long enough to pass a test question. He's now intending to forget it forever, and he's taught me nothing except how to cynically manipulate the system. Congratulations. And then obviously, that last thing is quite interesting in terms of me being a teacher. But the difference in life and the difference in maths is the ability to be able to understand the work, and that's being able to do it forwards as well as backwards. If you just regurgitate information for a test, great, you might do well for that test, but long term you're probably not doing yourself any favors. All right, so here's an example of doing things backwards. This situation, they've given me the value of a polynomial for a given value of x, but are asking me to find a value of a coefficient. So this time they're saying find r. Where is r? It's in my polynomial. And they're giving me this information here. Now, all it means is when I substitute the value of 2 in, out comes the value of 11. And that's all the information I need to help me find the unknown. So what do I get? I get 11 now is equal to 2. Substitute x as 2, because that's what this says. X value is 2, y is 11, or p of 2, or p of x is 11. So we're going to take away r and 2 squared. We're going to add on 2. And then we're going to add on 5. So 11 is equal to 2 cubed is 8. So that becomes 16 minus 4r plus 2 plus 5. Well, 11 is equal to 16 plus 2 is 18. Plus 5 is 23 minus 4r. Swap some things around so that 4r becomes positive. That becomes 23 minus 11. 4r is equal to 12. And so therefore r is equal to 3. All right, thank you very much. It's a whole number value. The chances are it's right. If I'd ended up with something like 2.67498, I may have made a mistake and may need to go back and check. All right, so make sure that when you are given this type of information that you know you can use it both forwards as well as backwards. Now, polynomial operations are just awesome. Remember, a polynomial is just a collection of x squareds, x cubed, x to the power of 4s, x to the power of 5s. And so in the same way, we can add polynomials, we can subtract, we can multiply, and we can divide. Or as I've written there, divided. That makes no sense. All right? So for example, if we're given that a function, let's call it h of x is that, and a different function called g of x is that, and it wants us to find the h of x plus g of x, all you do is literally that. All right, so h of x plus g of x is equal to 2x cubed plus 3x squared plus 2x minus 3. I'm going to put this in brackets and explain a little bit more why in a moment. That's h of x plus g of x, which is 5x squared minus 4x plus 8. Okay, in this situation, the brackets are completely redundant. I don't actually need them, so I can copy things out without the brackets, which is actually going to take longer than this whole video probably combined. And let's combine, let's collect like terms. So are there any more x cubed terms? No, 2x cubed. And I tend to put across through things when they're used. I've got a plus 3x, and I've got a plus 5x squared, which is plus 8x squared. I've got a plus 2x and a minus 4x, which is minus 2x, and a minus 3 and a plus 8, which is plus 5. Thank you very much. Now, if I had actually been asked to find h of x minus g of x, this is where the brackets come in critically important. So for example, if I had just written 2x cubed plus 3x squared plus 2x minus 3, so there's my h of x, and I'm going to take away g of x, which is 5x squared minus 4x plus 8. In this particular instance, that actually would give me a completely wrong answer. Why? Well, at this moment in time, this minus sign here, which is this minus sign here, seemingly only belongs to my 5x squared. But that's not what it's asking me to do. It's asking me to make it all belong to the g of x. So I should put brackets around this, which, and admittedly, the first term is fairly redundant, or the first set of brackets are fairly redundant. But now that would be minus 5x squared plus 4x minus 8, which would lead, once we simplify, to a slightly different answer. And again, we can use this to do h of x times g of x, or even h of x divided by g of x. Now in this situation, I'd probably use my CAS, unless the question was particularly evil and wanted me to do it longhand. Equating coefficients was the one thing in school I loved, and I loved and loved and loved it with a passion. Why? Because it was the one thing that actually makes sense. It was the one thing in maths I got first time. which is really weird now to think that I've got a YouTube channel and I'm a head of maths at a prestigious grammar school here in Melbourne, and I hated maths at school. Most of it just didn't make any sense to me. But now, because I struggled, hopefully I've got a way with being able to explain stuff. So basically, we know that an equal sign means that what is on the left of an equation, so the left-hand side, must equal the right-hand side. And it can be used to help us find missing values from polynomials. So here's an example. We're given this equation, right? And what we see is that we've got a cubic on this side, right, degree 3, and we've got a cubic on this side, but they seem to be in different forms. And on this side, we've got a value of A and a value of B I don't actually know. So what do? Well, we're going to equate coefficients. Now, because this side here is already multiplied out, we're going to multiply out this side. How? Well, there's a number of ways of doing this. And when I was explaining this to my particular group, and I'm going to do it again, there are ways called using Pascal's triangle. So Pascal's triangle is a very funky triangle, which basically says that these are the coefficients of what are going to be next to our multiplication of this, right? Now, when I take x minus 4 cubed, what I do is I take my x value, and I take my minus 4 value, and on one side I get x to the power of 0, x to the power of 1, x to the power of 2, x to the power of 3. So I count up on one side and I do minus 4 to the power of 3, minus 4 squared, minus 4 to the power of 1, and minus 4 to the power of 0. Now, why the power of 3? Because this is to the power of 3. And so long as, and again, it doesn't matter which one you count down and which one you count up, but in front of all of these, and I could have drawn this a little bit better, so let's just rub that line out to give myself some space. In front of all of these go the values from here, which is 1, 3, 3, 1. And I'm going to add all those together to give me my terms. And so how does this work in real life? Well, x to the power of 0 is 1. Okay, so now what we do is we multiply it across the line. So 1 times 1 is 1, and minus 4 to the power of 3 is minus 64. Then we do this run here, so we get plus 3x to the power of, well, not to the power multiplied by 4 times 4, negative 4 times negative 4 is 16, plus 3x squared times by minus 4, plus x cubed. All right, now this one here is x cubed because we've got 1 times x cubed, and anything to the power of 0 is 1. So let's simplify that. We get minus 64 plus 16 times 3 is 6, 12, 18, 48. Let's put the 4 in there just so we don't confuse anyone. X plus, oh, no, don't make a mistake there, minus 12x squared plus x cubed. Now, it's weird to have things written this way around. And so generally speaking, we would have, that's a cube, by the way, my pen's not finished off, we would have x cubed minus 12x squared plus 48x and minus 64. All right, so that is the expansion of that. And there's other ways of doing it. To be perfectly honest with you, if you were able to, I'd use your CAS, which I did a moment ago, and just checking it's x cubed minus 12x squared plus 48x minus 64. Good. So now, that's only, what did we say? That was only x minus 4 cubed. If I'm going to multiply that by a, I'm going to put an a in front of there. Remember, we're trying to get back to this particular function here. And then I'm going to add b, which means I need to add a b here. So taking this equation up now and multiplying it out, and still keeping the equation, we've got 3x cubed minus 36x squared plus 144x minus 198 is equal to, and I'm going to rub this arrow out because I've got a feeling I'm going to use all this space, is equal to ax cubed minus 12ax squared plus 48ax minus 64a, and we're going to plus b. Right, just enough. Now, when we're equating coefficients, remember everything on the left-hand side is equal to everything on the right-hand side, which means, because we've only got one x cubed term, that 3x cubed must be the same as ax cubed, which would suggest that a is equal to 3. Well, that's the first part done. That was nice and easy. How do we find the value of b? Well, b is part of this constant term. Now, the way I know it's a constant term is because none of those have an x or an x squared or an x cubed, so they must be equivalent to the number at the end. What is my number at the end? It's minus 198. So I know that minus 198 is equal to minus 64a plus b. Well, we know that a is 3. So 198 is equal to minus 64 times 3 is 12, 6, 12, 18, 19 is equal to 192, negative 192, plus the value of b. I'm going to add 192 to both sides, which gives me a fabulous total of b is negative 6. And if I was to put that into my CAS calculator and expand it out, I am pretty certain that if I put, what do we say, a was 3, x minus 4 cubed minus 6 into my calculator, that's actually what I would get out of this, right? So that is the funky stuff for this lesson, right? Basic information with regards to the language of polynomials. Hopefully you've understood everything. I look forward to seeing you next time.